Hello and welcome to our course on drone surveying. In today's lecture, we are going to focus on drone applications in urban planning. So, what is urban planning? Urban planning is the process of sustainable development and design of land use and the built environment. And this includes air, water, and all the infrastructure passing into and out of urban areas, such as transportation, communication, utilities, and their accessibility. Urban planning is a very interdisciplinary field that includes civil engineering, architecture, human geography, social science, and design sciences. And urban planning is really important because whatever decisions on urban planning or urban form are taken today, they will have very long term implications. Those decisions will have implications lasting beyond 50 years. So, they strongly affect a city's capacity to reduce greenhouse gas emission and respond to climate hazards over time. Urban planning is closely related with achieving Sustainable Development Goals (SDGs), such as pertaining to urban heat, air pollution, flood, energy systems, health, and community. And urban planning is a force multiplier for quality of life. So, if we want a good quality of life, we definitely need good urban planning. So, there are various agencies which are operating at different levels for urban planning in India. At national level, there is Ministry of Housing and Urban Affairs, which is responsible for National Urban Transport Policy, Atal Mission for Rejuvenation of Urban Areas, Smart City Mission, and Prime Minister Awas Yojana for urban areas. There is also Niti Aayog, which makes policies at national level. Then at state level, there are town and country planning departments, there are urban development departments, and there are state urban development authorities. And at metropolitan or city level, there are metropolitan planning committees, there are urban local bodies such as municipal corporation and councils, and development authorities which are present in some specific cities. And if there is a specific project, then that also has its own urban planning. For example, for special planning zones or industrial development authorities. And these authorities of urban planning are supported by Ministry of New and Renewable Energy, Archaeological Survey of India, Ministry of Environment, Forest and Climate Change, Jal Shakti Ministry, and National Disaster Management Authority. So, if we look at the process of urban planning, it has several steps. First of all, it starts with defining the problem and identifying the main issues and what are the goals and targets that we want to achieve. Then it starts with the baseline data collection, which involves collecting data about land use, what are the infrastructure which are present over there, what are the different environmental metrics, what are the current levels, what is the distribution of various demographies, what is the socioeconomic status in various pockets of the city, and so on. And then based on this, there is scenario development that takes place. This scenario development takes into account future growth projection. For example, it may be expected that a particular city will see a growth of 10% population in next 15 years, or there can be more demands of energy which are expected based on rising population of, let's say, EVs, or rising demand of more energy consuming appliances, and so on. So, scenarios are developed and simulations are done also based on including the effect of climate change. For example, that particular city may see more rainfall in the future, or it may see more rising temperatures in the future, and so on. Then based on the different scenarios which are developed, then planning proposals are made which take into account the land use strategies for different zones or zonations, environmental and infrastructure planning, and based on these planning proposals, then stakeholder consultation is done. Once all stakeholders are satisfied with the proposal, then the implementation process starts with getting the necessary approvals, starting with the infrastructure execution, and also enforcing that all regulations, all necessary regulations are kept in mind and they are all followed. And once the implementation is complete, then the monitoring of the urban area starts again. And this monitoring and evaluation happens through GIS dashboard. Now you can see there is very high requirement of GIS data in several of these layers. For example, in baseline data collection, in scenario development, as well as in monitoring. So GIS has a very important role in urban planning process especially since cities are always evolving. So there's always a need for updated and detailed spatial data. So GIS helps better understand urban needs. So it helps in understanding the urban needs by putting together vast information to balance competing priorities and solving complicated problems. For example, optimizing placement of certain buildings or community center, or optimizing the feasibility of waste disposal site or rainwater harvesting site, and so on. And GIS provides planners with spatial tools to visualize land use, analyze and predict environmental impact, and design infrastructure based on real world data. So, in urban planning, as you can see in the figure below, either GIS can directly be used through spatial querying and mapping and through various geoprocessing functions, or GIS data along with the non GIS data is used for spatial analysis and modeling, which again helps in informing urban planning. So GIS has very important role in urban planning processes. So if we look at various planning domains, we can understand better about what is the role of GIS or geospatial data in urban planning. So for example, in land use and zoning, GIS helps in identifying spatial patterns, regulating growth, and managing land supply. In infrastructure planning, geospatial data helps in locating the utilities, assessing service gaps, and optimizing utility and transport network. For assessing or planning for the disaster risk, geospatial data helps in mapping the hazards and vulnerabilities, and therefore helps in supporting preparedness for resilient infrastructure. Geospatial data also helps in heritage conservation by delineating the influence zones and regulating nearby development of heritage buildings. So the health of the heritage building is not affected by nearby development. Geospatial data also helps in housing and urban redevelopment by identifying informal or unregulated settlements or slums as they are commonly known, and also identifies potential for densification, or these are the areas in which we should invest more and we should promote more development in certain areas. Geospatial data also helps in environmental management by monitoring the green cover, pollution, and urban heat islands. Geospatial data also helps in supporting energies and utilities by assessing demand and potential for various renewable energy, for example, solar energy. Geospatial data also helps in climate and sustainability by evaluating greenhouse gas emissions and also finding out avenues for improving resource efficiency. And geospatial data finally helps in smart city governance because it is able to integrate real time monitoring from various data sets, for example, IoT sensors, from satellites, from conventional surveys, and therefore it helps build urban digital twins. So, where there are various techniques by which GIS is used in urban planning. So, first of all, that may involve having some base layer of land cover, then land use, then also involving having data of the three-dimensional building height and their distribution, as well as having information of the urban form and urban morphologies. So, all these strategies are used by urban planners to facilitate integrated mitigation and adaptation in cities. And it is done by reducing waste heat or greenhouse gas emission through energy efficiency, transit access, and walkability. It is also done by modifying the urban form and layout of buildings in urban district, which will again promote energy efficiency. It is also done by promoting the use of heat resistant construction materials and reflective surface coatings by identifying which are the best places where we can install these heat resistant construction materials or where we can install these reflective surface coatings. For example, if you have a house and the sun heat is usually very high on the southwest direction. So best place to install heat resistant construction material is on the southwest direction, and such decisions on a very large scale can be enabled by GIS. And also GIS helps in identifying potential for increasing the vegetation cover. So in addition to this, GIS is also used in public health and social services, such as for assessing spatial inequity in healthcare or amenities, for example, distance or accessibility to hospitals. And GIS is also used in urban land economics for understanding land development potential through land valuation models. Now, coming to India, Currently, about 35% of India is urbanized, which will increase to more than 50% by 2050. So, in India's fast growing cities, outdated or low resolution geospatial GIS data can create bottlenecks for urban planning. For most urban planning domains, conventional techniques are either very resource intensive in time and money, for example, through total station based surveys, or those conventional techniques may not be detailed or accurate enough for urban planning. For example, satellite remote sensing based technique. Hence, drone based surveying is fast emerging as a force multiplier for urban planning. And all government agencies are incorporating drone based surveys in some or the other capacity. So, if we look at drone based planning data sets, we are already aware that drones provide point clouds, so they can be photogrammetry or LiDAR based dense 3D representation. And then from these point cloud, digital surface models can be reconstructed, which are elevation data for all the objects. And from the DSMs, the digital terrain model, or which are bare earth elevation models, can be derived. From the DSM, high resolution RGB orthomosaics can also be derived, which form the georeferenced base layer for mapping. And from the DSM, 3D building models at various levels of detail can also be derived. For example, LOD1, which is level of detail 1, has just the block model as shown in image below. Then LOD2 or level of detail 2 has information of the roof structure, and LOD3 has even more architectural details. So, all these different levels of detail can be derived from digital surface model, which are obtained from drone based photogrammetry or drone based LiDAR. Then also drone also provides oblique imagery, which has information of the facade, that also helps in detailed 3D reconstruction. And if we can combine even more payloads, for example, thermal, multispectral or hyperspectral, then we get to know even more information about various materials which are present in the urban area. So these are showing some drone based planning application in urban areas. So these are, for example, site inspection, 3D modeling structure and terrain, master plan formulation, boundary assessment, area assessment, green space analysis, environmental monitoring, and heritage monument mapping. So if we look at some specific applications of drone, then drone is very useful in environmental monitoring and planning in urban areas. So sustainability of urbanizing built form in urban areas can be measured through the environmental performance of neighborhoods. And this can be through how thermally comfortable are those neighborhood, or what is the solar energy potential of those neighborhood. And variables like these contribute towards environmental performance. So planning support decision systems can also be developed. So these are decision making systems in urban planning that helps analyze environmental performance, and based on the environmental performance, it helps to identify which are the places where there's potential for intervention, there's potential for some kind of improvement. So on the example in the left, it shows a data set which is collected in Netherlands. It is known as the AHN data set, which is airborne LiDAR data, and the accuracy of this airborne LiDAR elevation information is 5 centimeter, and it has all the urban morphology and the building heights. And the goal of this study was to assess, if a new building is constructed, then what is the impact of this new building on the wind flow or on the solar potential or on the temperature. So they have the current situation over here. They added artificially buildings over here like this and this, and then they modeled the impact of these newly constructed building in some softwares which help estimate the impact on the wind pattern, as well as help estimate the impact on the mean radiant temperature. So now we can see in the image below that because of this building, the wind patterns have changed, or for example here the wind patterns have changed, and similarly because of these buildings, the mean radiant temperatures have also changed compared to what was present earlier. So these analysis help inform what should be the orientation of building, what should be the maximum permissible height of the building, or whether having new building or cluster of building can adversely affect the wind direction. Maybe the wind can decrease very much or it can increase very much. Also, if winds increase or decrease, that also affects the dispersion of air pollution. For example, if the winds decrease, then that may mean air pollution will get stagnated over there, and so on. So thus this kind of analysis or this kind of application promotes 3D data-based, data-driven decisions which make for sustainable and informed urban planning. Then drones can also be used for urban solar energy potential. So estimating available solar radiation on different building surfaces is important to estimate the feasibility of solar photovoltaic cells installation in urban built up environment. And for this, precise geometric information is needed to evaluate solar radiation on various building facades. For example, some of you may be aware that ideal location for installation of solar panel is when it is facing in the southwest direction and at an angle between 20 to 40 degrees. So one question can come to your mind: which are the ideal places or which are the best places to install these solar panels in a given urban area? So in this example, the authors have first of all collected drone imagery in a double survey grid fashion. So they use double survey grid over here because it was urban area, so they had to use double survey grid. And because they used double survey grid, then each place was mapped with more than 30 or 35 images. Then overall they had 400 plus images, and based on those images they created mesh model of this urban area. Then once they had the mesh model of the urban area, then solar modeling was done using Rhino Grasshopper software, which has a plugin called Ladybug. And then using this plugin, they were able to simulate what is the solar radiation at different times of the day and at different days throughout the year. Then they found the annual solar radiation map as shown below. So you can see that there are certain pockets in this urban areas which are mostly covered with shadows throughout the day and throughout the year, because of which they have very low or almost no solar radiation. So they are some of the worst places to install solar panels. So these are usually the parks between the buildings. On the other hand, they found that rooftops of these buildings receive solar radiation throughout the day and throughout the year. So rooftop are the best places to install solar panels. But not only that, they also found that certain facades of these buildings, so these are the side faces of these buildings, which are also good places for installation of solar panels because they receive very high solar radiation. So these are new findings that have come out of this study. And as you can see, not all the building facades have high annual solar radiation. It's only the building facades which are at a larger distance to neighboring buildings. Only those buildings have high annual solar radiation. If some buildings are very close to other buildings, then the facades of those buildings do not receive high annual solar radiation. So as you can see here, the facade of this particular building does not receive good solar radiation as shown by blue color, but the facade of this particular building receives good solar radiation as shown by high yellow and orangish colors. Then drone is also useful in infrastructure monitoring, as health assessment of strategic urban infrastructure is critical for planning appropriate maintenance operation and maintenance schedule as well as maintenance budget. Then traditional approaches are very expensive, they involve in situ test, and they can also be risky for operators in case the structure is already unstable. Then drone photogrammetry and drone lidar based non-invasive approaches have advantage because they are low cost mapping approaches, and in case medium level accuracy is acceptable, medium level accuracy of 5 to 10 centimeter is acceptable, then these drone based approaches are very suitable. So an example is given here by the authors. This shows a 3D model of a bridge which was collected using drone data, and the cross section over here, which is based on the 3D model from the drone data, shows various structural elements. Then this cross section can be compared with the AutoCAD file of that building, and based on that it can be found which places in that building or which places in that bridge are deforming compared to the CAD file. So this helps us in finding out what is the suitability or what is the health of infrastructure and whether more precise in situ tests are required or not. Also, drone can be used for performing bridge deck inspection. So in this case, the bridge deck or the road on top of a bridge was inspected and was identified for potential cracks or some potential deformities, and this can then be further inspected using in situ measurements. So drone basically helps in covering large area, and in case medium level accuracy is acceptable, then it helps in identifying which places need further interventions, or it helps in rapid assessment of various infrastructure monitoring. Drones are also being used for 3D urban digital twins. They enable precise reconstruction of building facade, roof structure, street features, vegetation, and microtopography. And all these are essential for realistic urban twins. And drones can access narrow lanes, courtyards, roof spaces, and dense built up areas. And this is specifically an advantage of drones compared to conventional scanners, which have line of sight problems or where satellite, because of the lack of resolution, cannot really see what is happening. So, this is showing an example of drone survey performed in an urban area by the authors. And from this drone survey, the building, land cover, and transportation related layers were extracted out. So, using the three dimensional information, different elements were extracted, and based on the height of the elements, whether it belongs to building, whether it belongs to land cover, or whether it belongs to transportation, were segregated. And these different layers then help in contributing the urban digital twin. Drones are also being used for pedestrian and vehicle tracking. Drones for video surveillance, for crowd control and public safety, as well as for vehicle traffic survey are being used. And drones are being used for automatic density map estimation, counting, and tracking purposes. So in this image, you can see results from the authors where they have used drone based data for crowd counting. So they are counting how many people are present in the scene, and this particular drone has edge computing. So it has a GPU which is also installed on the drone, because of which this crowd counting can take place in real time. And not only crowd counting, based on the video surveillance data from the drone, crowd trajectory can also be estimated. So basically, we can estimate or we can map which person is going where, which is very useful in identifying the behavior of pedestrians. So this helps in designing better pedestrians, better footpath, or in case a certain footpath needs to be widened or road also needs to be widened. So all these things can be done using drone based pedestrian tracking. Now there are some challenges in drone based urban planning application. First challenge is that pertaining to regulatory constraints. So urban areas are very dense, they have controlled airspace, they may also lie under security zone and may have geofencing limits. And because of these tall buildings, it may not always be possible to go beyond 120 meter, which is often a limit for drone in most countries. So because of these, drones face regulatory constraints in urban areas. Then urban areas by themselves have very complex urban geometry. For example, there are vertical surfaces, there are narrow alleys, there are repetitive textures which complicate the SFM and MVS algorithms. And because of these, it's often difficult to reconstruct facades, wires, thin structures, or even glass walls. And due to these, the survey in urban areas requires high GCP density because of poor satellite visibility. And in urban areas, also there is very limited space for taking off or landing. There are scarce open spaces, very small size of parks which are available, and not everyone may provide you access to their rooftop. So these are some complexities of urban geometry. Then because of this complexity of urban geometry, the GNSS signal also degrades. There is multipath from the buildings, there is signal blockage, which ultimately reduces the RTK and PPK accuracy. And because of reduction in the GNSS accuracy, that increases chances of collisions with buildings, with cables, or with trees. Then also there are concerns regarding privacy and safety. So if proper permissions have not been taken, then there is always risk of capturing private spaces, because of which there is very low public acceptance to use of drones in urban areas. And if drones are not being flown properly, then there is elevated risk of property damage and injury to people. So in summary, we can say that outdated surveys and low resolution data lead to poor or uninformed urban planning, which can be overcome tremendously with the use of drones. Drones are useful in urban planning because they enable precise, timely, and three dimensional insight into complex urban environments at various scales, from building structures to a neighborhood scale. And with the high level of detail, they are useful in creating digital urban twin, estimating solar energy potential, environmental planning, damage assessment, and pedestrian and traffic tracking. Thus, as cities expand and planning challenges intensify, drone derived intelligence will become more and more integral to building smarter, safer, and more resilient urban futures. So, that was all for today's lecture. Thank you.